Welcome to the next episode of the Qualogy Tech Series. Today's my colleague Michel Schildmeijer. He'll be talking about the open source monitoring of an enterprise-grade platform. I think it's probably open source stuff and Oracle and all the other stuff. So must be interesting. Michel, if you take over the screen, you can take it away. Oh, one more thing, I'll be monitoring the chat and the Q&A. So if you have any questions, put them in the Q&A. Over to you, Michel.
So, hello everyone. Welcome to my session of the Qualogy Tech Series today. I hope you enjoy it. I'll try to make it as much as interesting as I can. What I'd like to talk about today is about mixing two worlds together. And in my title, I've called it a open source monitoring of an enterprise grade platform, which is something I find very interesting to tell about and to share it with you. First of all, well, I don't know if you know me, but my mother always told me to introduce myself to anyone who doesn't know me. So here is my career path and sort of evolution. I was born in 1996 and went to kindergarten, junior high school, and then I studied clinical pharmacotherapy and joined the army. And afterwards, as a clinical pharmacist, I worked several years and switched to IT in 2000. And well, the rest of my career, I did a lot of stuff and ended up with Qualogy the last 10 years. And also some industry nominations like Oracle ACE and ACE Director. Okay, enough about me, because that's not where you are attending the session for. The topics I'd like to discuss today are the challenges of today about monitoring and managing all kinds of systems, applications, databases, infrastructure, everything actually, which comes in mind when you try to manage your IT infrastructure. Next, I'd like to focus a little bit more on my expertise of area, which is Java Enterprise and specific application servers, including also the path to cloud and container native landscapes. And also then comes in orchestrating it like with Kubernetes, which is pretty much the default standard for those things. And but that's not the whole thing. Furthermore, I also like to discuss about how to monitor the stack with a vendor neutral solution. So we have a lot of solutions in the market, but I'd like to tell you about how an open source project or several projects can be used for your commercial off-the-shelf products, which I discuss. And also, as last topic, I'd like to discuss about a little bit of the future trends regarding observability and telemetry. So when you look at the complexity of today's IT, then you can see a lot of different flavors, a lot of different areas where you have to stick in your thermometer to know how your system is doing, or how your application is doing, or how your database is doing. If you talk about operating systems like Unix or Linux or Windows, but also all the cloud providers, cloud vendors, all different flavors of database and all the technologies around that, big data, machine learning, all kinds of analysis, then you have to have some kind of a solution where you can say, I do have to put in some work, but this work shouldn't take too much effort in terms of implementing it. And I think I found this solution, and it's also highly adopted these days. So the complexity of applications as well, I already told you, not only the infrastructure and platforms, but also the multiple different languages you can program in, and all these things can make it more complicated to know what's in it, what's in your system, how it's running, if your application is failing or not. And I'd like to take you in that area. Furthermore, you also have a lot of data in your system, of course, moving around from the one system to the other. And it can be also structured data, of course, like what you put in your database, even if either it's relational or non-relational data, it doesn't matter actually. But you also have a lot of data. Well, maybe it's not garbage, but it's maybe sometimes not necessary data, and sometimes it can be useful. But what do you do with that data? This data can consist of log analytics, logs data. It can be runtime data from a running system, or it can be metadata, which can be used for steering a process in your environment. I'll switch off my telephone, sorry. So you want to get also something like, which is called operational control, either if you do it DevOps or not, doesn't matter actually, but also a traditional operational team likes to know about how the ITs, how their systems are doing. And it's maybe an open door, but it's still not always implemented everywhere. So you can you can implement monitoring into your systems to monitor uptime, to monitor availability and all those kinds of things, and also do some performance diagnostics. And you can also say, I want to do some predictive analysis. So you can also do a prediction on to predict how, when you might occur some peak loads during maybe the holiday season or some other events during the year. And with this data, you can also scale your system, for instance, to a larger size. If you know what's going on and if you know what's coming, then you can forecast on that. And you also can know you can detect more easily your weaknesses and your vulnerabilities within your system. Either it's bottlenecks in your applications, but also security vulnerabilities in all kinds of systems you have. And also you have to have a coherent set of data. So it's not only this one system or that other system, but also the entire chain of systems which interact with each other. It's useful to have this data into your monitoring solution. Well, if you look at the traditional tool stacks you have, there are a lot of solutions. I've shown you some of these solutions, the well-known ones like Nagios. And if you look at Oracle specific, then you have, of course, Oracle Enterprise Manager, which is a large suite of monitoring and also job scheduling and all kinds of management tools into one suite where you can use it for Oracle databases, but also for other systems, for any other application, Java application, for Java web application, or Fusion middleware stack, but also non-Fusion middleware can be implemented in that. And some other things are, if you look at more like Microsoft stuff, you have Scrum, for instance. If you look at log analytics, Splunk is a well-known one. And also, if you look at more the open source solutions, then the technologies I'd like to discuss, you can see them also here. All the technologies from the Elastic Stack and Prometheus and Grafana. So if you look at those four, if you look at Grafana and Prometheus, those are more for the runtime diagnostics, actually. So Prometheus is for gathering your diagnostics out of your systems, so collecting all the metrics, all the monitoring data, out of your systems and collect them into a central repository, where you can use Grafana to visualize these metrics into a useful dashboard for your teams. And if you look at other solutions for more like digging into log files, so more other data, then you can use some solutions of Elasticstack, which is Kibana and Logstash. And Kibana is in fact also some kind of a visualization for all the diagnostics you gather from your log files, and do also all kinds of analysis around it. And Kibana also has some APM capability, so application performance management. More or less the same like other tools you also have in the market, like Dynatrace, for instance. First of all, the topic was open source monitoring on a enterprise-grade platform. If you want to go open source, and if you want to also predict a migrate path from traditional infrastructure way of working to more a maybe cloud native way of working, then this part is also important to know about how you can do that. So I will first focus on a little bit on how to containerize a traditional Java application server from normal infrastructure to a containerized one. So if you look at this traditional Java application server, and you might not be surprised that in this case it's Oracle Weblogic, but you also have other application servers which can be containerized as well, like Tomcat, for instance, or IBM WebSphere. But for me, I will focus on Oracle Weblogic. So if you look at Weblogic itself, you have several components. You have Weblogic Server, and Weblogic Server has some subcomponents for caching, which is coherence. And there are also other caching solutions available, like Hazelcast, for instance, but within Weblogic, you can use caching for several purposes. And also is running, all is running on a Java virtual machine engine, and Oracle has its own JVM. You can also use open source ones. There's also a possibility to run Weblogic on GraalVM, for instance, where you can have a more polyglot Java application server running also other languages than only Java. And if you look at the side components, there you have your enterprise manager, which is in fact for your administration operations. And this is not the enterprise manager for the database systems, but a subsequent component for in the Oracle Weblogic Foundation stack. And using your development tools, which can be any Java development IDE, but the most used ones are, of course, JDeveloper and Eclipse, although that's also, yeah, maybe about your taste, what you prefer to use. And on top of that, you can build your custom applications. You can package your applications into all kinds of formats, or you can install Oracle Fusion Middleware on top of it. And when you look at Weblogic building blocks, when you want to containerize it, then you have several components to take care of. Weblogic is certified for all the containerization stuff, which is needed to build a container platform for Weblogic. And if you look at the components, you have, of course, container engines like Docker or any other container engine. It doesn't need to be Docker anyway. You can use any container engine which is available, but Docker is the most well-known one, and the pretty much the default, although it's changing this. And other tools to implement orchestration and containerization into your Weblogic application server is that you need an operator and all the components to gain this observability into your platform are like monitoring with an exporter, logging with an exporter, and also some extra tooling for migration, where you have your WebLogic domain on an infrastructure, on a typical infrastructure, then you can use some tools to make an export and put everything into a YAML and deploy it into your Kubernetes cluster. So this is about how it would look like if you would Dockerize or containerize, sorry, Dockerize is not the proper word, containerize your WebLogic application server into a container and run it in the end in Kubernetes. So you have your base image of Linux, which is a stripped one, so only the necessary tools which are needed for your operation. So not any extra tools, no necessary. So keep the image as lightweighted as possible. And on top of that, you can build in layers the other stuff within it, like the WebLogic JDK and the binaries libraries, an image of your WebLogic domain configuration and your WebLogic deployable apps. And that translates itself into a container runtime, and this container runtime can run in Kubernetes in pods. And a container in this case is then a Java virtual machine running in a container in a Kubernetes cluster, and an admin server, and in this case MS, which is stands for managed servers, are in fact Java virtual machines running a WebLogic instance. Next thing you need, because when you look at Kubernetes itself, it's an orchestration platform which can handle scheduling of your containers. It can load configuration. It can load volumes of data. It can configure your secrets and everything you'd like, but it doesn't know anything about what's inside this container. You have to have some relationship, and there's a concept which is called operators, and operators are in fact some kind of an extension on Kubernetes. And with operators, you can handle everything which is not specifically Kubernetes. So if you look at WebLogic, but also within database, Oracle also has created an Oracle database Kubernetes operator. And I know some people don't want to, or don't feel the need of doing a Oracle database on Kubernetes, but Oracle has some project, an open source project, and they wrote also an operator for database. But in this case, WebLogic has its own Kubernetes operator, and this handles everything which a Kubernetes pod never can do, like load balancing, high available lifecycle management for your WebLogic environment. Because if you say I'll delete my pod and I'll bring up another instance, that's usually normal standard way which you can do it, but within WebLogic you break off a process, in fact. So if something is running at that moment, then you might lose this process, and you don't want that. So do it more in a mannered way. And also for installation, doing a package installation with Helm, for instance, the operator is useful. And what I already mentioned, volumes, persistent volumes. So you don't want to lose, if your container dies, for instance, or gets affected, then you don't want to lose all your data within it. So you can create volumes, and this operator will manage these volumes for you and to persist all the data which is on it. And this is a short schema overview of how a WebLogic domain is implemented with the Kubernetes operator. So you have a YAML, an installed domain YAML, where all the inputs of your WebLogic domain, which are somewhat declarative, because YAML is also declarative. And you can configure all these items in this input YAML, and with this operator job, you can create a domain resource within Kubernetes, and the operator picks it up and will orchestrate all the containers and pods which are necessary to run a domain. So in the end, you get a running domain which you can access with a console or with a scripted tool. So these are all the things which the operator is responsible for. The logs can be published to Elasticsearch. You can do operational things with the operator, start, stop operations, deploy an application, everything. Next, for monitoring Weblogic and also monitoring what you install on top of it, you can use Prometheus, Grafana, and the Elastic Stack, as I already mentioned. But first of all, let me discuss a little bit about what is SOA in terms of what Oracle has for solution for that. If you look at this SOA generic landscape, then you have several components. This is a just generic architecture where you have your data services, which are extracted from your databases and your data. The process services are divided into business logic and orchestration. So orchestrate all these processes and get the data in the right place at the right time. And you can route all these data in and out using an enterprise service bus to your end customers, to your web portals. And in between, you also can use some workflow management using business process management. If you look at the Oracle solution for that, if you look at the technical solution, then it's built up like this. You have your operating system, you do your installation for your Java, your WebLogic, your SOA software. Then you have your domain configuration specific for your SOA environment. And after that, when you've done that, you will bring it up and create JVMs which run the Java, including the SOA specific configurations, using all kinds of resources like JDBC, JMS, HTTP, or maybe for monitoring JMX. And the result is that you have some kind of a bunch of Java application deployed. And these are all engines to run your SOA on top of it. So all the SOA components, which are in fact, or which are composites, and composites are some kind of a container which all the business data logic is included. And these composites you can deploy using this SOA Java EE framework. And this all will be translated into message-driven beans in AGBs, in web applications, or in some kind of a software adapter to integrate with other non-Oracle systems or Oracle systems at some other area in your IT infrastructure. So this is a bit of the process of how you can deploy your SOA environment into a Kubernetes-like environment. I can see something in the chat. Okay. Thank you, Jos. I will continue. If there are any questions, put them in the chat and I'll answer them at the end of my talk. So first of all, you would like to create your database because your database is important for your SOA actions. You would like to save your state of your processes which are running in your SOA infrastructure. So if you have some kind of a process which will extract some data out of a database, and it can be a long-term process because something changes in between, then you would like to save some state into some kind of a database solution. And Oracle has, of course, the Oracle database for that. And this database is created, and it's called the SOA repository. And in the SOA repository, all the state of all the composites and processes which are running are saved over there. Next, you have your WebLogic domain creation, of course, your WebLogic Kubernetes operator. And you have to create a namespace, and the namespace is in fact a separate area within your Kubernetes cluster where you can put all your resources in, and you can isolate it from the rest. So you can have some kind of namespace managed environment where only your components are running. Also, already told you about creating persistency. When you run containers in a Kubernetes cluster, then you don't have any persistency unless you can create, or unless you create a persistent volume and a persistent volume claim. And this persistent volume is a representative of a file system where you persist your data. And in my solution, I use the NFS-like persistent volume for storing all my domain configuration and all my log data. Now you can create secrets. I created a secret for pulling all the images out of my private repository. For my case, I stored all the secrets in my Kubernetes environment, but advisable is to create your, or to store your secrets somewhere else, like a vault solution. You can use any solution for that in the market. And when I did that, I created a database deployment, which constructed this Fusion middleware database. And this database deployment was also the RCU which you use to configure your SOA repository. And RCU stands for repository creation, which is a tool from Oracle to create a SOA repository. So you don't need to create a database and then load all the schemas needed for your SOA repository separate. It's all in one process. You also have to create a secret for that because you want to connect your SOA infrastructure, which is running in Weblogic, to connect to your database through a secret. And this is needed for your SOA Fusion middleware schemas. Next, you also create a Weblogic secret to access your Weblogic domain, in fact, and you also create a persistent volume for your domain. In this case, for the database, I've used the persistent volume for the data files. So if your container of your database goes down, also your data files are not lost. So next, you create a SOA Weblogic domain using templates, which are provided by Oracle, just Weblogic and OSB templates with the Kubernetes operator. And then some kind of an introspection takes place based on your configuration of your Weblogic domain. And if that's okay, then the job starts domain creation within your Kubernetes environment. And then the result is that you have a bunch of pods are running, the OSB server, the SOA server, and the admin server. And it depends on which you what you configured into your configuration, of course. If you do one, or if you do some scaling, elastic scaling within your domain, that depends on that. Next, you also have your Weblogic REST management API. The tooling of where the Kubernetes operator uses this API for all this stop start, but also for monitoring, which is important also for your monitoring using Grafana, Prometheus, and Elasticstack stuff. And it's all generated from the Weblogic mbeans, and mbeans are in fact small objects within your Weblogic environment for having monitoring in place. Okay, this was a bit about how to set up a Weblogic domain from a traditional stack to a more containerized one. Next, I'd like to discuss a bit about the framework which Weblogic uses to monitor, because monitoring with an open source technology like Prometheus Grafana is nothing more than a window glass of what's in the system. So you extract all the data which this particular Weblogic monitor framework gathers, and you load it into Prometheus and Grafana. So it's useful to know a little bit about this monitoring framework. Weblogic and Fusion middleware, which are in fact components which work together a lot. So Weblogic is in fact the standard Java EE application server, and Oracle build on top of that some kind of extra solutions, Fusion middleware solutions, which work together with WebLogic resources as well. But if you look at the frameworks which are responsible for diagnostics within WebLogic, then you have the default WebLogic diagnostic framework, and you have some additional stuff like the dynamic monitoring services and the Oracle Diagnostic logging, and also some kind of an incident management system, which if something critical occurs, then it can create some kind of a dump package. And in this package, all kinds of diagnostics data is included, like JVM dump, but also dumps of JDBC and all kinds of resources which are involved in this critical failure into your application, which is running in your WebLogic domain. And you also have some additional tools in terms of, you look at SOA, then you can also use selective tracing in combination with your Oracle Diagnostics logging. Sorry for that. Sometimes I like to talk a little bit too fast. And also some additional stuff when you particularly look at SOA for this state management. So preserve state, you can use some extra tooling within your database, which is called the dehydration store, where processes maintain their state. So if you have a process which is started in your SOA, then it gets the state running, for instance, and it's running until all kinds of operations are done within this process. And if it's done, then the state is finished or ready. And if a process goes wrong, then you can have a state faulted, for instance. And all these states are in your Fusion middleware repository included. And if some kind of a process is finished or faulted, then this stage is being written into a table. And this is called the dehydration store. And additionally, you have also the error hospital, which all the, as it might indicate already, which all the errors in your process which are occurring are saved, are stored. Sorry. Okay. So this is a little bit about the WebLogic diagnostic framework, which components are there. So you can use several components like watches and notifications. And these watches and notifications, you can configure them yourself, or you can use some kind of an out-of-the-box template. And these watches and notifications can be some kind of CPU load, or JVM performance, or watch stuck threads, or watch anything else which might cause a bottleneck. Image captures, you can also capture an image of your JVM. So like something like a dump as well, not it's a binary dump actually, which you can collect and gather and read it with some kind of tooling with that. But the watch and notification and data collectors are the most interesting one, because those are the ones which work with Prometheus and Grafana. So this is about where you can configure this. Okay, I'll go through that because I'd like to discuss a little bit more about the solutions of the open source tooling. First of all, I'd like to discuss a bit about the WebLogic logging exporter. And this logging exporter is a tool for exporting all the log data into Kibana and Logstash. And you have several components, of course, Logstash and Kibana, which you have to deploy into your Kubernetes cluster. You have a YAML for know what to export to Logstash and Kibana. And you have a YAR file, which you have to include into your WebLogic domain for being able to export all the diagnostics out of your log files. And also you have a YAR file in this case for part, because the exporter itself from Weblogic is written in Java. So you need to have some kind of translation, a parser and emitter for exporting all the data and putting it into the right format for your Kibana and Elasticstack. So you have to do some actions before you can get out your data. You have to install Elasticstack in your Kubernetes cluster. You can also do it outside the Kubernetes cluster, but if you do everything containerized, you should do that as well. Then you have to copy all the YAR files to your shared location. I will show you in a minute. And then you have to set some startup class within Weblogic to say, to make use of the startup class, which is also in this screen shown to you. And then you have to set up some configuration to export it. So this is the domain startup class to tell the domain, look at your domain environment and look for this specific startup class, which is included, let me go back in here, in your Weblogic Logging Exporter YAR. And then you have your Elasticstack configuration. This is the Weblogic exporting YAML file. And these are the components which come back when you have to configure Kibana for that. So you have to set up an index name, and this index name is used for your further log configuration within Kibana. And you have to have a Elasticsearch host, and this is a host which is running in your Kubernetes engine, a port, a domain UID, which is in this case SOA domain. This is specific for Oracle, not for other stuff, but specific for Oracle SOA suite domain. And you have to define something extra. Of course, you want to have everything exported, and you can also filter out which kind of severity you want to have exported. In this case, I used trace. And then you have to create an a pattern within Kibana. And this pattern I already showed you in the previous slide. This is the index name which is being used for your pattern in Kibana. And if you've done that, then you have your Weblogic servers exported, server logs exported and loaded them into Kibana. Now the open ends there are limits support for log files. This one manual upload for Oracle Diagnostics logs. I have to discuss that. You have two types of log, in fact, within Oracle Weblogic Fusion middleware. You have your Weblogic server logs and your out files, which are in fact dumps from your system, from your Java virtual machine into a text file. And next to that, you have the Weblogic logging handler, which export every message from your Weblogic domain into a log file. And when you look at Fusion middleware has its own specific diagnostics logging diagnostics, sorry. And this is in a separate format, separate from your Weblogic server. And if you have a component like OSB or SOA installed, then all the messages which are specific for SOA and OSB are put into these Oracle Diagnostic logs. So it's also useful to have all these Oracle Diagnostic logs into your Kibana dashboard. So I will show you. I will stop share this screen and share my other screen. Just a moment. Let me see if I have the correct one. Yeah, this one. Here it is. Hope everyone sees it. If not, let me know. So here you have your, first of all, I'd like to show you my Kubernetes dashboard. This is the namespace I already mentioned about. There are a lot of namespaces here. but in this case, I have here my SOA namespaces, and all my resources, all my pods, in fact, are installed in here. So I have here my SOA OSB server, and inside there, the Oracle OSB managed server is running, and the admin server and the SOA server at the same time. And here I have the Oracle database, which is the Oracle SOA Fusion Middleware repository. And besides that, I also have a Logstash reporter in here, which exports all the Oracle Diagnostics log. Anyway, if I look at, let's see, where's my, oh, here is my Kibana. So I have here Kibana. If you look at Discover, then I can choose two kinds of indexes, WLS. Then I get all the log files from the Weblogic server logs, and which are not the Oracle Diagnostics log. And you can do a lot with this. You can create dashboards with it, which I didn't do yet, but you can, based on all kinds of messages or filters, you can create dashboards with that. You can use Visualize for that, for instance. But when you want to add the Oracle Diagnostic logs, so you go to index patterns, then you can define the patterns there are. You can create an index pattern. In this case, it's the Logstash pattern for Oracle Diagnostic logs, which I already did. So I click that one, and then you can have some filters inside with a type of the filter. So either it's a string or a date or any other kind of format. You can import that into your Kibana. And the end result is then, if you select your Logstash, then you get here all the log files, content of your diagnostic logs. Okay, let me go back to my other screen. I will show you some more in a minute. Are you scared of my big head? So I already told you this one. Okay, and to add it to this Oracle Diagnostics log stuff, you can use a Logstash deployment to extend your Kibana with this Oracle Diagnostics log using this kind of configuration, which is an input and which tells you where the path of your diagnostics logs is, and also to filter out which kind of components you would like to extract out of this log file. And this is, of course, the Elasticsearch host where it should be published to. So it's very useful to use. Okay, next, Prometheus and Grafana. Already mentioned Elasticstack is more for the log file analytics, and maybe if you want to extend it with APM, for instance, then you can use it as well. There's also some kind of an overlap here and there in those tools, but for me, I think Prometheus and Grafana is more for real-time monitoring. So for Prometheus to implement it within your Java application server Weblogic and SOA, then you have to have several components. So you have to install Prometheus and Grafana into your Kubernetes environment. And next, you also have to have some kind of an exporter for that, because also the diagnostics data out of your Weblogic Diagnostics should be exported. Within Prometheus terms, it's called scraped. It scrapes it from an endpoint, in fact, and it's imported into a Prometheus data source. First of all, you need to configure Weblogic to be able to export it, and which means, in fact, that you deploy a web application which handles all these data. And one thing which I still have under investigation is the database exporter deployment, because all the states within the database, you can't read them with the traditional Prometheus and Grafana data source dashboards, because there is no support yet for mbeans out other than the standard WebLogic server mbeans. So this is a bit of the flow of how data is scraped and being loaded into your Prometheus environment. You have your WebLogic diagnostic framework, which I already mentioned some slides before, exported into with your WebLogic web application, and collected all the metrics which are coming out of your WebLogic diagnostic framework. So the watches, notifications, all those diagnostics data are all gathered by the WebLogic exporter and is being scraped by Prometheus. For an extra thing, you also need to configure a server's monitor for that. So you need to tell Prometheus, look into this endpoint and scrape all the data out of it. I will show you later in my Kubernetes environment. And if you configure your Prometheus data source, then you can set up your Grafana dashboard and load all the data from your Prometheus into a Grafana dashboard. So the integration is like this. You generate your export awards. It's very easy to do. Actually, Oracle has some pre-configured scripts for that. So you can tell these scripts of what to export, which managed server should it be, or should it be the admin server, what's the name of the domain. And then if that's done, if you run that script, then all the WAR files with a specific configuration for that specific managed server or admin server is generated. And the only thing you need to do is to deploy it into your WebLogic domain. So I did it all manually, of course, but you can do it also. You can include it into your entire CI/CD pipeline, all these actions, of course, to automate everything and to roll it out with a new version, with new monitoring data as well. So, and the end result, if you've done that and you've told Prometheus with the service monitor that there is a endpoint running and exporting the data, then you can tell Prometheus to scrape all the data and to implement or to import it into Prometheus. So these are all the endpoints which are running and which Prometheus sees. And you can also monitor within Prometheus itself when an endpoint is not up, when it's down. So you can create an alert for that as well. So if you don't get any monitoring data in, then you know that maybe the API is not, the endpoint is not running, for instance. So, and when you look into Grafana, then you need to have some, because if you look in, sorry, go back. If you look into this, then it's data, but it's not very useful. It's all kind of metrics, but you can do anything with it. So you have to have some kind of visualization. Within Grafana, I will show you in a demo later. You can create dashboards yourself. These dashboards are just JSON files, and in these JSON files, you can put in all kinds of queries you would like. And once you've imported all the metrics into Prometheus, then you can search within Grafana for these queries. And this is, for instance, a query which monitors the state of the WebLogic server, so if it's running or not. And Prometheus or Grafana doesn't know anything about which is running or not, so you have to add some value mappings into that. So you can say like value 0 is shut down and value 1 is starting. So then in the end you get in your dashboard is if a server is not running, then maybe some red flag is going or a red lamp is appearing that your server is down or is shutting down. And this is then some kind of a result of a dashboard, which you can configure within Grafana. I will show you in a minute in real life. Okay. Next, I'd like to discuss in short, if you look at SOA, and I already mentioned the SOA repository, which consists of a lot of SOA composite state data. There is a solution to export all the data out of your database using a solution which is called Oracle Database Exporter. It's an open source solution as well. And with this database exporter, you can extract all the tables you require of your database and let them scrape by your Prometheus environment. So actually the same setup with Weblogic is with the difference that everything is configured into a config file within your Kubernetes cluster. So you create a database exporter container based on an image, which is available on the open source on GitHub, sorry. And with the specific configuration, you can configure all kinds of queries into your configuration, and all these queries will be the results of all these queries will be exported and be loaded into your Prometheus. And these queries can be just DBA queries of how my table spaces are doing or anything, but also, of course, everything which is in your SOA suite schemas. So all the things which are in your dehydration store can be exported, like running composites, all the states of the composites, all the flows, everything you can export it. And for that, because Grafana also has a commercial Grafana plugin for Oracle databases, but as a replacement, not to pay for any license, you can use this solution as well. Now let me show you a real life situation of monitoring Grafana dashboard. Sorry, let me see where I have to be. Yeah, here. Okay, so here I have my Prometheus Grafana dashboard, sorry, and I have here some kind of a pre-configured dashboard. When you deploy Prometheus Grafana using the Prometheus operator, then your Kubernetes cluster is automatically included into your dashboard. So all the data is automatically scraped from your Kubernetes cluster. So you have a lot of data already there. So for Weblogic, you have this in here. So these are all the results of all the diagnostics which are scraped from your Weblogic domain. And if you look in here, the domain is SOA. The cluster is the SOA cluster in this case, but also can switch to the OSB cluster. And here are some of these metrics which are running. So I have one running server. The server state is running with this value mapping. The deployed applications, which are in fact deployed applications in terms of deployed WAR files, deployed AGB files. So it counts actually all the deployments which are running in a Weblogic domain. This is a metric which counts the free heap of your JVM. So if it goes beyond some kind of a limit, then it becomes red, and maybe you can set up an alert for that. This also monitors hogging threads and stuck threads. So hogging threads are in fact maybe on their time limit almost of getting a stuck thread. JVM heap and all kinds of other useful information like data source information about your connections to your database, your connection delay times, JMS connections you can look up here. So a lot of useful information. Go away here. But you can also add queries yourself if you like. So if you look in here, you have here within Grafana a metric which is called a metric browser. And here you can see all the metrics which are loaded into your Prometheus data source. And these are all metrics which are out of the box with your Prometheus operator. But at the end, you can see all here the WebLogic metrics which are exported and loaded into your Prometheus. So you can configure your dashboard yourself as well if you would like. But I would suggest to use some kind of an example JSON template, which you can use and then extend that one with your own metrics as well if you require that. Okay, it's all about time almost, so I will stop the share and go back. Right. Okay. Well, I think